This lecture is a continuation on that of absolute values. This will be a second in a series of lectures on absolute values. In fact, this will be forming absolute value equations and inequalities from words and word problems. Few prerequisites. You have to know about number lines and distances, graphs, and problem solving. And we're going to use all these to kind of combine them up and build equations and inequalities that involve absolute values. We'll first start by recalling our definition from the conceptual lecture that the absolute value of a minus b is just the distance between those two objects a and b. So, for example, the absolute value of x minus 7 is just equal to the distance between x and 7. And this is good because, if you think of it this way, that is, because then you'll avoid doing silly things like, oh, that's just x plus 7. A lot of people love to write that. It's not equal to that. So just note that it's not equal to that. Absolute values do not just turn things positive. That's not true. Absolute values are a distance, and so distances are somewhat tricky. Now, how do we use this absolute value notation to help us with word problems? Well, let's take a look at a couple. In this first example, we see that x is 7 units from the origin. And I want to translate this into an equation. And the way you should try to think about doing this is think of a distance, like something is, or better yet, I was writing it backwards, but it's better to actually think of it this way. The distance between something and something is something. Now, if you read this sentence here, they say x is 7 units from the origin. So we have to figure out what they're talking about. What are the distances between the objects, or actually, what is the distance? And then, what are the two objects you're finding the distance between? Generally speaking, whatever follows the word is our distance. So is 7 units means that 7 is our total distance that we're concerned with. And the two objects that we're concerned with the distance between is x, or x, and the origin, which is 0. The distance between x and 0 is 7. Let's see if that matches up with this language. X is 7 units from 0. In other words, the distance between x and 0 is 7. And if you translate that to absolute value notation, distance between x and 0, that means the absolute value of x minus 0, means equals, and 7. That is read as the distance between x and 0 is 7. By the way, that's not the best way to write that because x minus 0 is just x. So the absolute value is equal to, the absolute value of x is equal to 7. And it takes more than one example to actually understand this, so let's do another one. X is 7 units from 2. Some people really do find it easier to maybe create a number line, and then they think about, well, what are the two objects on the number line? X is 7 units from 2. Well, 2 is definitely on our number line. And then likely x is also on our number line, either over here or maybe to the left of 2. So we want to know what's the distance between 2 and x. So let me write that down in language. The distance between blank and blank is blank. The word following is here is 7. So obviously the 7 will go afterward here. And then the two objects we want to find the distance between are x and 2. So the distance between x and 2 is 7, or in other words, x is 7 units from 2. That's the distance away from 2 that x is. Written as an absolute value, the distance between x and 2 is just the absolute value of x minus 2. Is the equal sign, and then 7. That's an absolute value equation for this word sentence, the English sentence. This one's strange because it's not k is 10 units from negative 5. It's k is within 10 units of negative 5. Again, we want to write this out in a different format. The distance between blank and blank, so there's our two numbers we're finding the distance between, or our two objects we're finding the distance between, is, and then I put a blank here, a couple more blanks. First of all, let's talk about the two objects we're finding the distance between. So is it a distance between k and 10? Well, it can't be a distance between k and 10 for a simple reason. If it is, then the distance we're looking for is a -5, and distances are never negative. So that means a -5 is going to be one of the objects we're finding the distance between. But also, it's that k and -5 are within 10 units of each other. That's really what it's saying. K and -5 are within 10 units of each other. In other words, the distance between k and -5 is something like 10. But it's not really 10. We can't say it is 10 because we don't want it to be exactly 10 units. We have to be within 10 units. Now, within is a very strange word for inequalities. Some people could argue that it means you can actually be 10 units away. Some people can argue successfully that it means that you can't be 10 units away, you have to be closer than 10 units away. I get to see either. So I'm going to pretend as though this means that you can be at most. But it just depends on somebody's interpretation. I personally think that within means at most. Just because if I say I'm within 50 feet of my car, that means I'm 50 feet or less away from my car. But again, within is a very ambiguous term. So the distance between k and -5 is at most 10. So what does that mean? Well, the distance between k and -5 means the absolute value of k minus that -5. Remember, it's the difference of those two numbers. And then something about 10. At most means it could be less than and it could be equal to, but it can't be greater than 10. The most it could possibly be is 10. Cleaning this up means that k plus 5 is less, the absolute value of it is less than or equal to 10. So this one's a little bit more challenging just because of that word within. If I had said k is at most 10 units away from -5, then it would have been a lot easier. R is at least 5 units from 2. So again, I'll just go ahead and write this in that language, the distance between stuff. So the distance between blank and blank is, well, there's our relationship. So what's the two objects that we're finding the distance between? Well, let's see, R and 2, the distance between those is at least 5. So the distance between R and 2 is, and then I'll say at least here, at the very minimum, 5. Well, the distance between R and 2, that's an absolute value, R minus 2. It is at least, meaning that it can be bigger than it, and it can actually be equal to it, 5. If you have a very difficult time with this inequality business, think about this. If you make at least $5, that means you can make more than $5, right? You can make 6 or 7 or 8. But it also means you can make 5. So there you go. Now this is where, this type of example that is where most inequality, absolute value inequality problems shine. This is called a tolerance problem. And a tolerance problem basically means you have a machine doing something over and over again. It's allowed some error. In other words, think about filling cans of soda, 12-ounce soda cans, with soda. They don't really have exactly 12 ounces worth of soda in them. They have plus or minus some error. Some have a little over 12 ounces, some have a little bit less, and they allow that. Well, here's a lumber yard that allows the thickness of a piece of wood that they cut to be no more than 1/100th of an inch from 3/8 of an inch. So let's go ahead and label some variables here. We'll let T equal the thickness of the wood, and we want this thickness to be no more than 1/100th of an inch from 3/8 of an inch. In other words, the distance between blank and blank is no more than blank. Well, no more than blank, we know no more than 1/100th of an inch. So I'll put the 0.01 inches. That does say a 0.01 inches. I just couldn't fit it in there. And then the other two things we have is the letter T and 3/8 of an inch. So in other words, the distance between T and 3/8 must be no more. In other words, it can be less than, the distance between these two things can be less than or possibly equal to 1/100th of an inch. Yeah, I didn't put inches on that on the number inside, so I shouldn't put inches here. And this is actually how a lot of machines are manufactured. They have this absolute value inequality dominating. They say, oh, we allow some error. The error here is 1/100th.